The advantages of micro-CHP. Focusing on the client's point of view and looking at, do you want CHP? If you have CHP, what should you do with it? And should you upgrade your plant room to include CHP? Adveco Limited is the distributor for A.O. Smith water heaters and has been for the last 50 years in the UK. We're better known as A.O. Smith, but for the last 10 years, we've been working to develop a secondary product range to focus on improving our offering to provide renewable and high-efficiency products to go alongside our A.O. Smith hot water systems to decrease our customers' carbon footprint and increase efficiency. Under the A.O. Smith brand, we have gas-fired water heaters, indirect and storage tanks, electric water heaters, solar, thermal, and boilers. And under the Adveco brand, we have alternative water heaters, boilers, and cylinders, as well as buffer vessels, plate heat exchangers, heat pumps, and CHP. As a company, we're focused on the supply of full plant rooms with our products in them. And we do this by being involved in the design and by providing expertise on which products to use and how these systems go together and operate in the best way to meet customers' requirements. We can provide a full design service to the end client. However, many of our customers are design consultants. We work with them to meet SBEM carbon and efficiency targets under Part L, which is their main requirement. For this reason, we've promoted a lot of Totem CHP units in the last 5 years through consultants. So what is CHP? CHP is a small power plant in your building. Through a use of an internal combustion engine directly coupled to a generator, it turns natural gas into electricity, and then we capture all of the heat of that process and use that in the building. And that gives us a big reduction in energy and carbon costs. So, do you want CHP? In my opinion, there are enough benefits that you always want CHP, but the benefits might not be large enough to make it worthwhile to buy it outright on a purely business case. If your building has CHP, it's because someone made the decision to select it based on either a financial or an environmental case. You want it once it's in because CHP has that environmental and cost savings impact, but it'll only provide a payback case on CapEx in the right type of building, which is why you might not want to buy it if you don't have that sort of building. It will have been put in to meet designers' priorities. The designer's first priority is to meet the carbon savings required of the building in order to build the building. That's their number one priority. Second of all is the outlay price of the job to build the building. If there's a CHP in your building, it's likely because it was the most economical way to meet the carbon savings required of the building. However, the designer's priorities and the client's priorities aren't necessarily the same. The first priority for the client is the reliability and functionality of the building. The building must have heat and the building must have hot water. That's the number one priority. Second to that is the operating costs, the costs of keeping the heat and the hot water on. And finally, the environmental impact is important as well, but after the building functions at a budget. So, what do you do with your CHP? Well, CHP is a non-critical support technology. It makes no difference to the reliability of the supply of heat and hot water to the building. Water heaters and boilers are critical equipment. If they break down, the heat and hot water supply to the building is reduced. But whether CHP is on or off doesn't really matter. The building still has heating and hot water. So you need to make a decision. Do you run the CHP or do you shut it down? If you shut it down, you spend nothing on maintenance, nothing on energy consumption by the unit, and you have no loss of heat or hot water to the building. You'll have no carbon offset either, but that's not the top priority. Alternatively, you invest to keep it running. You pay for maintenance, you pay for the energy consumption by the unit, but you gain the benefit of the CHP. So the benefits of operating a CHP. Well, first of all, there is increased system resiliency, especially for the domestic hot water. Operating cost savings, coupled with the right sort of maintenance plan to make sure that there's no risk to those savings. And environmental improvements, both NOx and carbon savings. Combined heat and power is typically coupled with the domestic hot water system to provide hot water to the building. It's done as a preheat system to give it the long heat up time in between the peak demands, and you have an afterheating system to make sure that at all times you can supply the hot water to the building. It shows there one water heater as an afterheater, but likely for a commercial building there would be two, and often they would be set to 60% each. So in the case of failure of one, you still have 60% of the load of the domestic hot water. CHP adds to that resilience. The CHP preheat vessel is typically sized for most of the morning load. So even in the case where a water heater was not operational, the CHP would provide a large percentage of the required demand. So there is added resilience from a CHP, leading to more protection of the system, protection of the supply of the system. Operating costs. Operating costs are determined by the electricity offset plus the thermal energy offset, less the energy consumed by the unit and the maintenance costs. So the key inputs are the cost of the gas and electricity, the cost of maintenance, and the run hours per year. The maintenance is important. There's two maintenance offerings that the client can select. There's a basic pay-as-you-go scheme for both the maintenance and the repair. As you need service, somebody comes out and you're charged for the work that's done. And there's a full charge per run hour maintenance offering, which includes all maintenance and repair. That full maintenance is like a long-term warranty policy. It removes all of the risk from the payback calculation. It ensures that the payback calculation is met. It allows for long-term budgeting. And of course, it costs a little more than the basic maintenance plan. It will extend the payback period by a little bit, but it means that you have no risk to those savings over the period of time that the unit will be in. Well, that's important because costly repairs reduce savings. And CHP is an automobile engine. It's got highly stressed moving parts, which will lead to necessary repair over time. You need to protect that investment with a full maintenance plan. So once the cost of maintenance is decided, the operating cost can be determined based on the electric and gas prices. CHP is better when gas costs less and electricity costs more. Over the last 5 years, it's really moved in the favor of CHP. You can see there the non-domestic, medium-sized gas and electric rates since quarter 1 of 2015 through quarter 2 of 2019. Electricity's gone from about 10 pence per kilowatt hour up to about 12 pence per kilowatt hour, while gas has gone from 3 pence per kilowatt hour to about 2.5 pence per kilowatt hour. So it's moving in the favor of CHP. And it means that the savings per hour from CHP has increased since 2015 from about £1 an hour to about £1.50 per hour. And those figures there are real figures. They're taken from the quarterly government gov.uk website showing the different non-domestic rates for different sizes of buildings, and I've selected the medium figures for that. So currently, a T25 25 kilowatt electric unit will save £1.50 per hour. So then the savings is determined by the run hours per year. Now, due to some of the carbon requirements on things like the London plan, the CHP may have been put in to meet those carbon targets, and the run hours per year might not actually be all that high. For example, to meet a London plan, it wouldn't be uncommon to see a CHP running for about 2,500 hours per year. So that might meet the carbon savings of the London plan, but it may not be enough to provide a true payback on the unit. It saves about £3,750 per year in that scenario, £1.50 per hour and 2,500 run hours per year. So 3,750 is good savings if the unit was installed when the building was built and then it was inherited by the client and you're not actually looking at the CapEx of it. If you're looking at the CapEx of it, then it might not provide you with the savings that you would need to install one. So, should you upgrade your plant room to include CHP? Depends on the run hours. That's the key. If the estimated supply and install cost of a 25 kilowatt electric unit is 50 grand, and the savings per hour, and this includes maintenance, the full maintenance, savings is £1.50 per hour, then you'll need 33,333 run hours to achieve payback. If you want to achieve payback in 5 years, that's 6,700 run hours per year, which is equivalent to 18 hours per day. The potential savings over 10 years then is £50,000. An 18-hour day average over the course of the year is either 18 hours per day every day of the year, or if you capture longer hours in the heating season, then you could have perhaps 24 hours during the heating season and somewhere between 12 and 14 hours per day outside of the heating season, depending on how long the heating season is, depending on the ratio of heating to non-heating days. So to get those sort of hours in the summer when there's no heating load, you need something with a big domestic hot water load. Something like hotels, halls of residence, prisons, large nursing homes, multifamily accommodations, depending on where the electricity is going and how much the landlord is responsible for. And I've put leisure facilities on there as well, because that's a situation that also has a large thermal load in the summer, where it would be the swimming pool in this case, as opposed to a large shower demand. So if you're upgrading your equipment, a realistic payback to achieve should be 5 years if your building is suited to the technology. And this will typically now be better than PV because the feed-in tariff is gone. And it may be easier to install an internal technology like CHP compared to a rooftop technology, especially in big buildings in urban areas. The CHP will get better payback than an air source heat pump. And again, no external space is required. Sometimes heat pumps can have challenges on where they'll be located. Okay, the other advantage of CHP is the environmental savings, both carbon and NOx. NOx is all about air quality, and it's and air pollution. Air pollution is made up primarily of NOx, and the Royal College of Physicians did a study a few years ago where they estimated that 40,000 deaths per year in the UK were attributable to poor air quality. Most combined heat and power systems emit less NOx emissions than grid-supplied electricity. But the problem is the location of that power generation. So right now, if you look at the area around London and the large carbon-based electrical generation plants, they're not in the city. They're not in very built-up areas. They're on the outskirts. They're in less built-up areas. And that's important because it means that the NOx emissions from the generation of electricity aren't in urban areas. But CHP units will be in urban areas. So any CHP should have a positive effect on air quality from a national point of view, but can have a negative impact on local air quality because the emissions of generation have now been brought into the city. CHP will only have a positive effect on local air quality if it's cleaner, less NOx emitting than the boiler that it's offsetting. The CHP provides thermal energy which the boiler doesn't have to run, so it reduces the run hours from the boiler. So it's the comparison of those two to determine the effect locally of the CHP on air quality. So selection of a low NOx CHP is vitally important. And depending on when they were developed will have a lot to do with what their NOx emissions are, because as CHPs have been developed over the years, they've gotten cleaner and cleaner and cleaner. There's a bar chart showing various different CHP units. The totem there on the left-hand side has NOx emissions less than 10 milligrams per kilowatt hour. That's less than the condensing boiler, which is 35 or 40 milligrams per kilowatt hour, that it will offset. It's also less than the BREEAM limits. It's incredibly clean, so it actually has a positive impact on local air quality, not a negative one. Carbon savings. Carbon savings are achieved through the use of CHP. It's changing, though, because the grid-supplied electricity is getting much cleaner, and especially since about 2014, 2015, there's been quite a strong downward trend in the amount of carbon emissions from electricity. And that's getting better because there's an increase in wind and solar, and therefore less coal. But on average, CHP still provides a carbon benefit over the year. On days when the carbon intensity is over 188 grams per kilowatt hour, the CHP provides a benefit. Now, the actual intensity of the grid fluctuates seasonally and daily depending on the demands on the grid and what the renewables can supply. So CHP will be carbon advantageous at sometimes a day, but maybe not at others. Here's a day in February of 2018 where at different points during the day it was below 188, but for the majority of the day it was above 188. And so for most of the day it would have been beneficial. And seasonally, looking at the same thing, there's the years from 2013 to 2017 showing the average amount of carbon emissions for the production of electricity by month. So you can see in January there it's quite high, it's almost 400, and in December it's still over 300, but in June and July it's quite low, it's around 200. But you see 188 being the threshold at which point CHP is no longer beneficial. At all times, on average, it was beneficial. Carbon intensity of the grid is higher when it is dark and when it is cold. And CHP requires a thermal load to operate. So it naturally aligns itself with the higher carbon intensity when it provides the biggest impact and the biggest savings. So in the future, smart controls will be used to adopt the CHP runtimes to ensure that it operates when it has the most impact. So for example, a CHP that runs 14 hours per day, the smart controls will ensure that the 10 hours that it doesn't operate aren't when the carbon intensity is the highest. It'll align the off periods with the clean grid periods. So, in summary, the right CHP can provide carbon savings and improve local air quality for a building. CHP can provide a useful energy cost savings for a building. And with the right type of building, upgrading to CHP will provide a good payback period. And CHP has lower running costs than a heat pump, and both higher savings and an easier install than PV. And it always makes sense to run existing CHP, and it makes sense to purchase for the right type of building. Thank you very much.